Optic Refraction by Michael Salcedo, David Guzman, Savelli Yepes, Mario Contreras, and Alder Fernandez.
Optics is a branch of physics that studies the behavior and properties of light, such as reflections, and the main topic of our demonstration, which is refractions. Simply, refraction is when light passes through two medias and the direction of light changes. The famous Pink Floyd album uses the idea of refraction on their album cover, with light entering the left side of the prism. Once it has entered, the speed of light slows down, bends, and changes direction. The light then refracts more, exiting the prism. Longer wavelengths tend to refract less, while shorter wavelengths tend to refract more. The angle of refraction orders the wavelengths displaying visible light spectrum and a rainbow exiting the right side. The same idea applies to rainbows that appear from rain. The white light from the sun enters the droplet, dispersion happens, the light then gets refracted, exiting the droplet, and the rainbow colors exit. Snell's law is used to calculate the degree of refraction and in relation to the incident ray.
Okay, this is the analysis of our experiment. So we successfully recreated the rainbow. This means that refraction did indeed take place. And obviously from what we researched, of course, it means that the sun rays went from one medium to another, which was the air to the water droplets. They'd slow down and they would exit from different angles than what they would originally enter from. The order of the rainbow also shows us something that we researched, which of course is wavelength. The longer the wavelength, the harder it is for that ray to refract, which can be seen with red, as it's on top, so it's refracting less. And towards the bottom, we can see purple and yellow, also blue, which have shorter wavelengths. This allows them to quote-unquote bend more than red, which of course is just refracting. With both of these together, it's obvious that we successfully replicated refraction in our own backyard. Additionally, a system with a mirror and water was made in order for us to obtain quantitative measurements. Here are pictures of our system. It's a mirror submerged in water, and we simply use a flashlight as a light source. You can also see in the photos that we highlighted the incident ray, which is the ray that goes from the light to the mirror. You could also refer to this as a quote-unquote original angle of the light. And we can also see the reflected ray highlighted in green, as well as on the wall after it's reflected. Here are our calculations for the angle of refraction. So for our calculation, we'll be using Snell's law. To do that, we'll first plug in our knowns and then just solve for our unknown. The n's are the refraction indexes. For air, it's 1, and for water, it's about 1.33. Our thetas are the angles. Theta I is the angle of incident, or the angle of which light comes in. This is 33. The angle of refraction is what we actually calculated. We simply plugged in all of our knowns and solved with a calculator. The resulting angle of refraction turned out to be 24.17.